Hello everybody, my name is Craig Bennett, and today I am going to get into a Elite Dangerous video, and I'm going to get into how realistic is some spaceships within certain games. Now, I've done videos like this in the past, and the past one I've done is Star Citizen, so feel free to check that out. But in this, we're going to be taking a look at the Anaconda within Elite Dangerous. Now, one big thing I want to mention is this is one of the top of the tier ships you can get in this game. Not the top tier, but definitely up there. Now, as far as things goes, this is the size of something like a football field, or maybe a little bit bigger, and it's very difficult for me to express scale within this game because, you know, the space and everything's huge. But the fact is I'm going to be focusing on, can this thing really go from atmosphere to space, space to atmosphere, or is this only stuck in one or the other? Now, unfortunately, because how the game is, I cannot explore the inside of the ship. I mean, I can probably take a look around the cameras and take a look at things and see how I would prove it for pilots and whatnot. But other than that, you know, it's not like Star Citizen and some of the other games out there at this time. Now, for those of you who are wondering, yes, I do have a background in aerospace. I've even been in newspapers multiple times, dealt with NASA, and so on, so on. Done this in some past videos, but feel free to check that stuff out if you're interested. But with that, like some of the other videos I'm be doing, one of the biggest focuses I'm going to get into is energy. How is energy transformed into the ship? So if we take a look at this real quick, being Star Citizen, it's actually easier to show this. So the first things first is, where is the ship going? So normally it's going to go this direction, and this means that we need to figure out where is the energy going to go. So the energy is going, and that's actually a bad color. So the energy is going to go towards the back as the thing is flying through the an atmosphere. The atmosphere pushes on it and pushes back, but also you have forward momentum from the thrusters. And the thing is you have to keep in mind that the energy of the back and front is going to meet somewhere. Is it going to be the middle? Probably not. Is it going to be somewhere a little bit left or right? The middle? Maybe. So that's a big thing. And plus, is it going to meet, like, let's see if I can fix this real quick so I can show you. Is it going to meet more towards the left or right side of things? Like, say for example, more towards that side or that side. I think it's going to be more in the center because it's very symmetrical, so that's one of the benefits we have with this particular ship. But where's it going to meet from the front to back, I honestly can't say, and that's really more of a difference between the atmosphere and how much thrust you're going to put in the back. So it's also going to change that. So as far as things goes, you're trying to look for weak points, especially around the center part of it. And the fortunate thing is until we get more towards the back area, the weak points don't really show up. So let's try to put this a little bit more into the light, and we can see that we have energy bleed out places. So what I mean by this is, because I can't see the internal structure of the ship, I have to assume that, let's just say, it's more or less solid. So where's the energy going to flow? It's going to flow towards the edges more than anywhere else. Obviously, there's going to be some in the middle, but it's more towards that because energy flows to the weakest points, just like pretty much everything else. So what that means is you're going to have the energy bleed off point there, and as far as the energy that's going from here, it's going to bleed off in those areas too. Plus on this one, it's going to match up probably closer to here. Where's that one's going to match? So you're going to have two forces meeting right there, and will that hold up? Now, the interesting thing with this is, if we take a look at this, let me try to get in here and do a full stop. So if we take a look at this, is if we go to the bottom, we honestly don't have much of a bleed point down here. It's more of a rectangle right there. So it's more than less. If we try to go to the other side, we can see that it's more into the wings itself. And this actually adds quite a bit of a benefit into itself, which is actually quite interesting. So what's going to end up happening, I can't get any closer than this, but what's going to end up happening is, if I can draw here, is basically we have energy coming from front there. It's going to meet somewhere around here. Energy coming from the back here. And because this is hooked up not directly to the stuff, it's going to be going more for here. So this energy is able to bypass it to some extent, and you're not going to really have a lot of cracking here. Now, one of the interesting things is because since this is considered as part of the wing and not a part of the internal structure of the ship itself, you can have sacrificial material here. So what does that mean? Let's say, for example, you have two energy forces, one from the front, one from the back, and then in the middle you got sacrifice of material. This means that as the two energies push together, you can have something in the middle where it actually crushes it on purpose, so it bleeds out energy at that point without having the energy travel to another spot. And you just have to replace that sacrificial material. So times that you might be able to see this, like in the future in some futuristic spaceships, is like you don't know all the atmospheres that this thing's going to go through. If it's going to be a thick atmosphere, if it's going to be a light, or all the other scenarios that will play within it. So let's assume that you don't know. So let's just say that something happens, something has to go through a thick atmosphere. You don't want the energy to travel into the ship itself. You want it to stay within the wing area. So as it is going from the front to the back, and the back to the front, you're basically pressurizing that to the point where it will crush and the energy will flow outward, which is the best case scenario. So, and you just go to a port, whatever, and they'll replace that part because it's sacrificial. It's easy to replace, easy to deal with, and you just move on from there. So that's an interesting feature that could be right there, because I mean it's just two small spots, one on each side. Something that is very interesting if they did design it for that. It feels realistic. So one of the other things that I found quite interesting with this is the wings itself. Again, the thing is this is huge. I honestly can't tell you much about how well this will go through the atmosphere because it's so big, and we honestly never moved anything like this through our atmosphere in real life. But just based on raw looks, I mean, I could be wrong because something like this would be very easy to test if you can get a model of it. But just by looks, I'll be questioning how well it will fly through the atmosphere. See, the thing is taking a look at this. Let's say, for example, that this is going to go through an atmosphere. Now, you might think that, well, it'll be going straight to the atmosphere, and that'll be all fine. And that's how you probably would do it now. Now, realistically, so the captain is around that area. Their view is pretty much that. They're not seeing how to get down, because the fact is if this was real, so let's say, for example, the ground is that way, they would actually have to be approaching something like that. Well, more so that this will actually be tilted up quite a bit of a degree. So let's actually simulate that a little bit. So it will actually be something like that, where it's actually going against the actual atmosphere and making the entire thing almost like a wing, and it's going down like that in the ground. It's that level. That's the thing is the captain will never ever be able to see how it's landing, and once it gets below to a certain point, it can level off and do its thing. But as it's going through the top layer of the atmosphere until it gets into it, it would never be able to actually see how well it's doing. And even then, once it gets into the atmosphere a good ways, due to the short wingspan, I honestly kind of doubt that this will have enough lift to allow it to glide. Best way I can describe this is think of it as a pencil versus an airplane, a paper airplane. So make a paper airplane right now if you want, and throw a pencil and then throw a paper airplane. You know, same strength and whatnot, as straight as possible. And you'll find that the pencil doesn't really make it that far at all. Well, if you take a look at the wingspan of this is pretty much a pencil. And what it needs to be is a paper airplane. Honestly, I would think that I could be wrong again, but based on raw looks, because, you know, I don't have any software to throw one of these ships in, or don't have the physical model of it to throw it into a wind tunnel, but just based on looks, I would highly question how much lift it can get, and will just drop pretty much like a rock. Maybe last a little bit longer than a rock, but pretty much drop like a rock all the way through the atmosphere until it hits the bottom and everybody dies. So with that, I would definitely not want to be on one of these ships if it was going through the atmosphere. Obviously, space to space, that, you know, you can literally have the Borg cube if you want, but atmosphere space, or even atmosphere to atmosphere, I don't think this would do anything realistic without extreme amount of power. You can definitely do whatever you want. You can make a brick fly. That's pretty much airspace. How do you make a brick fly? How do you make a brick fly? How do you make it go in space? How do you make it orbit around the planet and come back down safely? Well, yeah, you can throw a crap ton of fuel behind it, which, you know, happens all the time in space industry, but this is going to be making regular trips, hopefully, to the ground, and that means that this needs to be able to easily get down there without using much fuel, because that means cost. And you know, more moving parts, more problems, whereas wings, you know, you don't really have as many problems there as you would engines. So with that, that's a major thing, is without using a crap ton of fuel, I would not want to test this going into the atmosphere. That's just a major thing. Now, one of the other things that I would definitely, it's kind of hard to do with this because how close you can't get to it, but one of the things I'll be worried about, and this is the same problem I have with some Star Citizen ships, is where does water get into? Now, this ship is a bit better than Star Citizen's ships, a lot of them, but, you know, it's not ton better. See, the thing is in the engines and stuff like that, I'm not too worried about it, but the thing is if we take a look at things, is if we got any liquid, it can go in areas like this, that, and a few other areas. And what is the problem with that? Why do you not want liquids to be able to go into those certain areas? Well, what can happen is once the liquid turns into a solid, it can actually crack things. Throw a Coke can, unopened Coke can, into the freezer and see what happens. Or a glass bottle that's unopened, you know, fill with, you know, whatever liquid, and just make sure it's filled to the brim and see what happens when it freezes. Or even the bigger issue, because this thing does go into the radius of the sun to actually fuel up, so it actually has to go and be superheated at times. Guess what happens when gases turn, or liquids turn to gas? They expand like crazy. So what that means is you can literally blow off parts of the ship. So for those of you who don't know, there is something called a linear ship charge. if we take a look at this leadership charge, this is, let's say for example, we have a part right here that we want to deal with. Well, a leadership charge will basically be something like this. There's several different shapes onto it, but most of them are like that. And anyways, the point of this is where the explosive power all goes to the center part, which goes here, and it does a cutting force on it. And whenever you see like a line on some rockets, that is the leadership charge. If not, fuel lines or whatever, but chances are it's the leadership charge. And the point of that is, if you got like a solid rocket, then the only way to get rid of the fuel, as far as get it to stop moving if it's already lit, is to get rid of all the fuel at once, and that's the only way to do it. So with that, the gas can literally act as something like a leadership charge, which can, no joke, crack the ship in half, and that's a problem into itself, especially if it gets into too much of a crevice. So you want to prevent from that if all possible. So with that, there is problems like you would see in some other space games, but a lot less on here, believe it or not. But still, this is enough of problems that I would be worried about. Now, you might be worried about, okay, what about in the future where you got space or exploration? Is that going to keep us from exploring any gas or water planets? What the fact is no. What you can do is, around the doors, like right here, you can actually create a heater along the edges, and that would actually keep the gas from turning into a liquid, or turn to whatever, or a liquid from turning to whatever, depending on what the chemical is, and that will keep the problem from happening. So I mean, you got what you got, and you just got to clean it out, but it would just maintain whatever it is depending on the chemical. So there's things you can do about that, and like I said, with engines, I'm not as worried about that because they kind of stay hot as is. Some of the areas I probably wouldn't worry too much about it, but as far as some of these other areas, especially with the electronics and pipes exposed and all the other stuff like that, those are the prime targets for something like that to happen, and bad crap happens very fast. Obviously, if something is staying in space all the time, this will be less of a problem. And in my opinion, my humble opinions, this ship is absolutely best to stay in space and just avoid going in atmospheres at all costs. So with that in mind, I mean, like, obviously you can go on the moon or something with low atmosphere and probably fine, but I wouldn't go on like an Earth atmosphere or Venus or something like that, because you probably won't ever be able to get it off the ground. So with that one in mind, that's pretty much sums it up. This is good for space to space, but honestly, this is not a good ship for atmosphere to atmosphere or atmosphere to space, because you probably won't even get off the ground. And if you do, you got to use a metric ton of fuel to just get it off the ground. Now, assuming that you're okay with using a metric ton of fuel and storing a metric ton of fuel somewhere, because it's quite big, why? There's much more efficient designs than this, and it wouldn't take much more material than what you got now to do it. I mean, you can use a lot of the fuel tank and make it into wings, and you can achieve better results. So anyways, honestly, if I was to purpose something like this, something this big, I would have it as a small fighter holder, and something around to that. But it'll always be in space. Maybe a big hauler or something like that. But again, it'll always be in space, or very, very low atmospheres, and it'll probably be fine there. But anyways, as far as that goes, if you got any questions, anything else, and let me know. If you thought I got anything wrong, then feel free to leave that in the comment section. I'll take a look at it and maybe correct things if that's the case. But if you want me to cover a different ship in the future, a different game, or some type of ship in some type of game, then let me know and I'll try to take a look at that. If this includes regular airplanes and you know, fantasy airplanes, and I would tell you good and bad with that. Again, you know, like with this, I can get a little bit more into it. This is honestly not a bad pilot situation and stuff like that, because you got a good viewpoint and whatever. But the unfortunate thing is due to how the ship is and how the game is, I cannot really look inside and, you know, say, oh, this is good or bad. I just have to assume with outside and go with information I'm able to visually see. But anyways, if you got any questions, anything else, then feel free to let me know, and I will take a look at that. And hope you have a great day.